Hello everyone, and in today's video we're going to be talking about how you can use ChatGPT in Azure OpenAI to chat with your data. This is a very powerful and exciting new feature that got recently introduced and is currently in public preview, and I'm really excited to go through that today. It allows you to leverage models like GPT 3.5 on your own data without necessarily coding or doing any of the training required to be able to accomplish this. In our previous video, we talked about how you can fine tune in Azure OpenAI. In today's video, we'll be diving deep into retrieval augmented generation, when you should be leveraging fine tuning versus retrieval augmented generation. We're also going to be looking at the architecture of what's happening underneath the hood that's operating or making this feature work, some considerations you need to keep top of mind. Then we're going to go to the Azure OpenAI in Azure in the Azure portal and configure and connect our cognitive search to Cosmos DB. And finally, we'll then be deploying that into a web app, which would communicate with our data using ChatGPT. First things first, if you found this information or you learned something new from this content, please feel free to like, comment, subscribe. It really helps out with the algorithm. And without further ado, let's get started.
All right, so let's talk about this idea of fine-tuning or retrieval augmented generation, also known as RAG. And in my last video, I mainly mentioned how you can leverage Azure OpenAI to fine-tune. But when would you consider fine-tuning and when would you consider RAG, right? So sometimes, for those who are not very familiar with these two concepts, is that sometimes when we are working with a language model such as, ChatGPT to do a specific task. So this task can be like answering questions, summarizing text, or writing stories, or anything like that. The text data that actually the model was actually trained on might not have information or examples for the task that we want. So for example, in ChatGPT, the data that has been trained on extends all the way to September 2021. So anything that happens after that, it won't have the necessary information to retrieve that knowledge, right? And there's other tasks maybe that are more domain specific. And how can you work around this issue with with the LLM not having that information that you needed to retrieve? And this is where this idea of RAG and fine tuning comes in, right? So let's talk a little bit about fine tuning. So fine tuning is just a way of giving the language model, in this case would be like ChatGPT, extra knowledge by basically retraining it on a new set of text data that is related to the task that we want to accomplish. And in this case, you are actually creating a completely new model than the one that is that you're originally retraining. On the other side to that, you have RAG, and it's a way of giving the model, extra guidance. And the way you do that is not by retraining it, it's by retrieving some relevant text data for each task that we wanted to do, and then later injecting that retrieved relevant text in the actual prompt that is being sent. So this might sound a little confusing, but we're going to get into some questions that we can ask ourselves in terms of how can we guide our decision making of whether or not we can fine tune or use RAG. And in addition to that, I think it'll be a lot clearer when I'll show the architectural example of how RAG gets implemented in our use case today and what we will be demonstrating using the Azure OpenAI service mixed with Azure Cognitive Search. So how can you guide basically your decision making of whether or not you should be using fine tuning or you should be using RAG? And there's a lot of different ways you can come to this conclusion, but one way is to ask yourself just a few questions, and the answers to these questions is going to really help you give you confidence as it relates to which approach to use. So the first question is, how much task-specific data do you have? So fine-tuning requires a very large and high-quality data set that basically covers all the different scenarios that you want your model to handle, and this basically means that you need to have enough text data that is not only relevant, but representative of the task that you are retraining the model on. And that can be very, very expensive and time consuming if you need to constantly update the model, and in this case, would be retraining the model. So from RAG's perspective, or Retrieval Augmented Generation, you can work with smaller and more dynamic data sets that basically can be retrieved on demand. So if you've ever worked with, Bing, Bing uses RAG to basically retrieve data that is found in the web and send it back, and that's how it's able to give you that response. It's able to use the internet or other sources of information as your data set. And that's how it's able to generate new data and understand what's happening currently, all while not having to be being retrained in the back end. So that's the first question that you really need to ask yourself. So the next question is basically, how often do you need to update your model's knowledge? And I touched on this a little bit earlier in the previous point. But if you need to retrain your model very frequently, basically to incorporate new information, then RAG might be the more convenient and logical approach here. If you can afford to retrain your model less often, then fine-tuning might be more efficient given the use case that you are looking for. The next question is basically, how accurate and coherent do you need your model's output to be? A lot of the time, if you've worked with, ChatGPT, not a lot of the time, but sometimes you would see that there's a lot of hallucinations, right, that happen when you're asking questions. So one thing you have to understand is, do you need your model to have high accuracy and coherence in terms of the answers that you're retrieving if it doesn't have that information? In that case, if you really need that, if you can't afford for that information to be sort of hallucinated, then your fine-tuning might be a little bit more suitable. If you can tolerate a little bit of errors or some very minute inconsistencies, then RAG might be a little bit more flexible. And finally is, how important is it for your model to cite sources or provide provenance? And this question basically relates to sometimes you might need your model to justify its answers and show where it's getting its information. So if you go back to the Bing example, when you ask Bing a question, it would actually cite every single source that it would use to retrieve that particular information, right? But if you don't care about that, then fine-tuning might be a little bit more simple from an implementation perspective. So these questions should guide you in terms of what you should be fine-tuning, when you should be fine-tuning, when you should be using RAG. However, I should note that, in a lot of the different cases and with a lot of different customers, you'd see that RAG would often be sufficient for the particular use case. Rarely do I see or my coworkers see fine-tuning be a real solution to the business problem that the customer or you are trying to solve. So it should be noted that for a majority of the use cases, RAG should and would be sufficient.
So I think it's important, as always, to have an understanding of the architecture behind the demonstration and the tutorial we're going to be going through today, where we will be leveraging the Azure OpenAI service, more specifically the Use Your Data feature that is currently in preview. So there's a few things in this architectural diagram that I just want to go over. One of them is the knowledge base. So in our first release, we support documents like .md, .pdf, the Word, PowerPoint documents, and we can connect our data by either connecting directly to our Azure Cognitive Search index, which would have data sources connected to it, such as Azure SQL or Cosmos DB or any other supported data source. Or we can directly upload from local files, or we can connect directly to our Azure Blob storage. So the maximum limit that we actually have for uploading files, if that's the route that you want to take, would be around 16 megabytes. For Blob, we don't have any restriction, but the amount of time would basically depend on the ingestion itself. So in general, if you have a very large data set, it's recommended that you first connect your data source to Azure Cognitive Search, and then in your Azure OpenAI Use Your Data service, just connect your Azure Cognitive Search index. So after we receive that data from that knowledge database, what would happen is we would ground and we would chunk that data into Azure Cognitive Search so it can be used to be retrieved from a query. Then we are going to have a web app, and this web app is going to be deployed directly from the interface, and nothing you have to manage. This is all going to be deployed for you. And then we're going to have a fully managed chatbot that would respond and deal with only the data that you fed it into Azure Cognitive Search, and then we're going to be doing some queries. So the full architecture would be, we're going to send our model some data, and this data comes in the form of like a question, based off of the data that maybe we have in our Azure Cognitive Search. Is going to be facilitated by an app orchestrator, and this would be the Azure Web Apps. Then this query is going to be basically ran through in our Azure Cognitive Search to be retrieving the data that is most relevant. Once that data is retrieved, we're going to be getting some results. Those results are going to be fed into the prompt in our Azure OpenAI service. The result then is going to be shared back to the user, which would be us, through the web app that is orchestrating this whole flow. So that's just a high-level overview of what we are actually going to be doing. Just a quick note on the idea of private endpoints. Right now, private endpoints are not supported with this feature. However, when this feature does go GA, we might have this feature introduced. So just something to note that currently private endpoints are not supported. So let's head on over to our Azure OpenAI service in the Azure AI Studio. And you'll see that there's a few additions that happened in our previous tutorial, which I'll be leaving somewhere in the screen for you to click to. I think it would be a good way for you to have a quick introduction of how you can navigate around this. And in the previous tutorial, we went over just the basics of all of this, as well as how you can fine tune, leverage the OpenAI API through the Python SDK. So if you haven't already checked it out, we'll leave a link in the video whereby you can do that. And now you see that there's a few things that got added. One of them notably is the content filters here. And basically it's a way to ensure basically the safety and the quality of the outputs in the model. So the Azure OpenAI service has built-in systems that filter out harmful content from the prompts as well as the completions. And the system actually uses a combination of different models that classify the content and then prevent it from generating any offensive or inappropriate material or content. So basically you can either add your own, but it already works alongside this content management already works alongside the models, but you can also add customized content filters as well. Then you have different quotas, and these different quotas basically is how much you can use. We have these metrics called TPM. Every model has different tokens per minute thresholds, and you can increase these service quotas through submitting a request quota ticket here. Then we have these data files. We went over them in our last video, the models that we can choose from. For GPT-4, you have to submit a ticket for that. And I think it would mention it here, get access to new features. And this would be in this part here. Then we also introduced DALL-E, but I think it's only available in US East. So your Azure OpenAI service would have to be deployed in US East. So what we were mainly concerned with is the actual chat playground here. And this is where you can leverage your deployment, which maybe leverages the GPT-3.5 Turbo. If you don't have that already, you can go to deployments here, create a new deployment. As you can see, it's leveraging the GPT-3.5 Turbo, and I just labeled it or named it ChatGPT. So we can go back here and have that selected. And as you can see, we have the assistant set up. We have a system message and the add your data feature. So the system message is basically just instructions on how the model should behave, any context that it should have when it's basically generating a response. So this is a way you can give the assistant some personality, what it should or shouldn't answer, how it should do those things, and how to format particular responses. There's no particular token limit when it comes to the system message, but every time you're chatting with the model, it will be, the tokens will be included from the system message to the overall token limit. And that is something just to keep in mind, however. So if we go on the add your data in preview here, you'll see that you have an ability to add your data source. If you have the inability to do this here in this playground, you may not have like appropriate roles or permissions. So if you have, for example, the OpenAI reader role, you would need to have a contributor role for you to be able to do this. And as you can see, we can add a data source here, and you'll see that there's different data sources that we can select from. There's Azure Cognitive Search, blob storage, upload files, more coming in the future. But just something to know while we're working through these different data sources, because Azure OpenAI is using your data and is creating additional, it might need to create additional resources like Azure Cognitive Search indexes. You might not have these permissions. So, and these permissions are not part of the reader role or the cognitive services OpenAI user role. So you may need to have permissions for those particular services to create those resources to begin with. And like I said again, currently in this feature right now in preview, we don't have support for private endpoints. So that's something to you would need to think about. If you're leveraging Azure Cognitive Search, you would need to make sure you have the contributor, the Cognitive Services OpenAI contributor role, the search index contributor role, and I think there is one more, but just make sure you have all these different roles in the different data sources that you're actually going to be leveraging. So in our case, I can either use Azure Blob Storage, I can either upload files, but I told you about the limitations of that. Azure Blob Storage, if you have tons of data, it's probably not very feasible. Or what you can do is you can leverage Azure Cognitive Search. But before we actually do this, because this is what we already have connected to our Cosmos DB database, let's click on Azure Blob Storage. So you'll see that here you have the subscription. You have to select which storage resource you want to have access to. And then you need to have Azure Cognitive Search resource. And again, the reason why is because we need to ground and chunk the data and be able to retrieve the data in a particular way where it is going to be leveraged in your prompt. If you don't have Azure Cognitive Search resource, if you don't have one, you would have to create one. And then you would have to input the index name. Since we already did those things, I already have my Azure Blob Storage connected to my ADLS, or I already have my my cognitive search index already created for Cosmos DB. I just need to go on Azure Cognitive Search here. Now we select our Azure Cognitive Search service. For me, it's search for data OpenAI. Then we select our index. For me, I've already created the index for Cosmos DB in my Azure Cognitive Search. So all I have to do is find that, and it's this one here right here. It's called Cosmos DB index. Yes, I acknowledge there's going to be some usage. And I click next, and here you can fill out these fields in order to have nicer citations when the answers are being generated. I'm just going to leave this empty for now. And this is if you want to add semantic search within Azure Cognitive Search. This is something you can do from here as well. So we're just going to click next as well, and then we're going to save, and then we're going to close. And now what we have done is we have directly connected our data from Cosmos DB. And the Cosmos DB would be here. This is our container, and there's like these documents that are all been indexed by Azure Cognitive Search, and now can be retrieved. And if we go to our Azure Cognitive Search service, and we go to our indexes, and then we go to Cosmos DB index over here. You're seeing that it scanned all these documents. If you want to, upon creation actually of not the indexes, but the indexer I'll show you in a second, you can set a particular time frame in which you can refresh Azure Cognitive Search so it can index incoming data that it probably hasn't indexed before, right? So you have all these different fields in our Cosmos DB container here, and you can see I selected all of them to be retrievable. allow them to be filterable, sortable. For example, I want the timestamp to be sortable. And these are all things that I've done in Azure Cognitive Search. So if we go back over here and we go on our indexers, you'll see that we've done this. It was a day ago. And if we click on it, you'll be able to see that this was the date and what we did for that, and was it successful or was it failing. And this is what I was telling you before. You can create a schedule in terms of when this Cosmos DB indexer would run. So I did it once. You can do it hourly, daily, or you can have a custom time frame in which this would be essentially refreshed. So what does this all mean? So we've done all of this. So how can we actually interact with that data now? So if we go on our Cosmos DB, and maybe we select, okay, we want to know the phone number for the person, Reeves George, that has this username. So what we can do now is we can go back to our chat playground and we can basically ask, what is the phone number for the username Reeves George? And let's see what gets returned. And then it will give you the phone number for the username is this particular phone number. And we go back to our Reeves George, and you can find the phone number here. And this is how it's doing it in the backend. It was just able to, because this data has been not only ingested into cognitive search, it's been indexed, and all these fields are retrievable, and can now Cosmos DB can actually read. Sorry, not Cosmos DB, but Azure Cognitive Search and Azure OpenAI can interact with each other to generate responses in sort of like a chatbot-like way. So this is really cool, right? But how do we use this? How can we leverage this? How can we distribute this maybe to our organization? Maybe this is something for us. And what we can do is we can, on the top right here, it says deploy to. This is also in preview. It says a new Power Virtual Agent Bot. You can deploy it into a Power Virtual Agent Bot or a new web app. So if you click on a new web app, you can create a new web app, which would be done here, or you can update an existing web app, and the web app would be, you can select it, and I actually have one over here. This is web app for deployment, and now I can click on deploy. So this would take a few minutes for it to load, and when it does, I'll be right back. So now, as you can see, the web app has been deployed, and I did want to mention just one quick thing. So this whole interface is stateless, and that means that once you exit out of this, it doesn't actually store any of that information that you've added, right? It wouldn't store this particular data source that you've added. So you need a place where this can be deployed and then it can be used. And this is why we are deploying this to a web app. And before we do that, actually, before we launch this web app, if we go back to our Azure portal here and we write app services, you'll see that now it's deployed under app services. This is what's orchestrating the connection between your Azure OpenAI, your cognitive search, everything else, everything that's running in the backend, it's all deployed for you in a very, very simple step. So if we click on this, I did want to mention that there is a way for you to actually see the code, and this is actually written in Python, and there's some configurations that you can create or you can do within this particular configuration, because this is what the application is using to authenticate for there's also certain things like how many documents can you search for, and let's see if I can find that. That it will only take the first 5 documents. You can play with this value and basically change it if you need be. And you're seeing that custom area pages requires a premium app service plan. I just had a basic one for now. And if we go on Deployment Center, you'll be able to see that it is actually connected to a GitHub repository, and we can go on to the main branch here. So this is where the entire code base of the actual application that's running on app services is contained. And if you go on the app pie, this is the entire code that's running on Flask, and it's showing you the exact all these steps that are necessary that are happening for the application to run. So I just wanted to mention all these things. If you see that there's certain things that you want to configure, it's probably in the environmental variables here that you can check on settings, and you can see everything that has already been predefined too. I know that in one case, for example, you would want to have the ability to see how much Azure Cognitive Search can actually retrieve, how many documents at a time. This is set to 5. You might want to change it to more. You see that do you want to be able to use semantic search or not? The default option is set to false, true. And I'm just showing you this to see that sometimes you might wonder why you don't have the ability to customize it in the chat playground, but you actually do have the ability to do it in the configuration when you actually go to your web app development. So now, because once I've clicked the launch web app, you'll get a page similar to this. So now we can actually interact with this as if it was something like ChatGPT, but in the back end, it is leveraging ACS, Azure Cognitive Search, and the index that we created for Cosmos DB. Now, one thing that I did forget to mention, that if you go into Chat Playground and you click this mark or this checkbox, which just says limit responses to your data content, then that's only going to, as it implies, it's only going to respond to information that has been fed from ACS and the index that we created for Cosmos DB. So if you go back to the chatbot here and we ask it, a simple question such as, tell me about the fields and the documents you have, and let's see what it says. Personal such as names, address, and job titles. Can you tell me everything you know about the person with the username Reeves George? And then you'll see that the documents you provided, it'll give you all the answers. It'll give you basically everything that it knows about this username. Because if you go back to our playground, or not our playground, but our Cosmos DB, you'll see that it's basically retrieving this information, and you're having a conversation with that data as if it was already trained and equipped with that knowledge, because it's leveraging retrieval augmented generation. This is going to conclude our demo and tutorial. If you've learned something new, please feel free to like, comment, subscribe. It really helps out with the algorithm, and I really appreciate your time. I'll see you in the next one.